we are going to discuss some properties of a Laplace transform. First we discuss about a linearity property, then first shifting property, second shifting property, and if time permit at the end of a lecture we discuss about a change of a scale property and the numerical problem based on a first shifting property, second shifting property and change of a scale property. So let us discuss about a linearity property first. Linearity property of a Laplace transform. So what is the linearity property of a Laplace transform? So property means here we write linearity theorem. Also this one is known as a linearity theorem. Okay. So what is the statement of a theorem? Statement of a theorem is if Laplace transform of a f1t equal f1s and Laplace transform of a f2t equal f2s, then Laplace transform of a c1 f1t plus c2 f2t equal c1 time of a Laplace transform of a f1t plus c2 time of a Laplace transform of a f2t. So equivalently we may also write this one equal to c1 f1s plus c2 f2s. So as c1 and c2 be any constant, where c1 and c2 be any arbitrary constant, So how we prove the linearity property? So proof of a linearity property is based on a what? Based on a definition of a Laplace transform. What is the definition of a Laplace transform? Laplace transform of any function ft equal what? Laplace transform of ft equal e to power minus st, integrate from 0 to infinite, e to power minus st ft dt, e to power minus st ft dt. Now using this definition, Laplace transform of a what? c1 f1t plus c2 f2t equal what? By the definition of a Laplace transform, in place of ft, what we write here? We write c1 f1t plus c2 f2t. So on the right hand side what will happen? In place of ft we write what? In place of ft we write c1 f1t plus c2 f2t. So this become what? E to power minus st in place of e to power minus st. In place of ft what will write? We will write c1 f1t plus c2 f2t. c1 f1t plus c2 f2t dt. Now again using the property of a definite integral, what will happen? Zero to infinite e to power minus st c1 f1t plus c2 f2t dt. So using the property of an integral, property of a definite integral 0 to infinite e to power minus st, then we write multiplied in a first term e to power minus st into c1 f1t plus dt plus 0 to infinite e to power minus st c2 f2t dt. Again, using the property of integrals, since c1 is a constant, so this one become outside from the integration. So c1 0 to infinite e to power minus st f1t dt plus again c2 with a constant, so it's become outside from the integration. So this becomes c2 integrate 0 to infinite e to power minus st f2t dt. Now again using the property of what? Again using the definition of a Laplace transform. So by the definition of a Laplace transform, this one is a Laplace transform of a what? This one is a Laplace transform of a f1t. So this becomes c1 Laplace transform of a f1t plus c2 Laplace transform of a f2t. So if here if we write the left hand side Laplace transform of a c1 f1t plus c2 f2t equal c1 Laplace transform of a f1t plus c2 Laplace transform of a f2t. So this one is approved. So what is the application of a linearity property in order to solve the numerical problem? So if there is a combination of a two function, addition of a two function with multiplication with some constant. So here f1t is multiplied by c1. So if we have a Laplace transform for f1t, then this one equal to the c1 time of a Laplace transform of a f1t. In particular case, if c2 become what? c2 equal to 0, then Laplace transform of a what? Laplace transform of a c1 f1t equal to what? c1 Laplace transform of a f1t. Means c1 become outside from the Laplacian operators using the what? Using the linearity property. So here Laplace transform of a c1 f1t equal to c1 time of a Laplace transform of a f1t. Now we solve one numerical example based on a linearity property. So here we write in order to save the time, already we write one problem. What is the problem? Problem is find the Laplace transform of a following function. First function is a 3 into e to power 2t plus 4 into e to power minus 3t. Second one is a sin t minus cos t whole square, and third one is a e to power at minus 1 upon a. c1 Laplace transform for ft plus c2 Laplace transform for gt. So here if we try to find out the Laplace transform for this first function, ft is a what? Here let ft is a what? 3 into e to power 2t plus 4 into e to power minus 3t. So what is the Laplace transform? Here now LFT taking Laplace transform of ft Laplace transform equal Laplace transform for this whole function 3 into e to power 2t plus 4 into e to power minus 3t, and here this become using the linearity property 3 into Laplace transform of e to power 2t plus 4 into Laplace transform of e to power minus 3t. So as we know that Laplace transform of e to power at is a 1 upon s minus a. So here we write 3 into e to power at, the value of a is a what? The value of a is a 2. The Laplace transform of e to power at is a 1 upon s minus a. So Laplace transform of e to power 2t become 1 upon s minus 2 plus 4 into e to power minus 3t 1 upon s plus 3. So, if we simplify this, this becomes 3 upon s minus 2 plus 4 upon s plus 3, s plus 3. So, if we simplify, this become s minus 2 and s minus 3, and in a numerator this become 3 times of 3s plus 3 3 is a 9 plus 4s minus 8, 4s minus 8. So, if we simplify, this becomes 7s plus 1 upon s minus 2 and s minus 3. This is the Laplace transform of a what? Laplace transform of a 3 into e to power 2t plus 4 into e to power minus 3t. This one is the answer. This one is the answer. This one is the answer. Similarly, if we try to find out the Laplace transform of a second function, second question, ft equal sin t minus cos t whole square. So, if we simplify the braces, then this become sin square t plus cos square t, and this become minus 2 sin t cos t. So, we may write this one. So, we may write the sin t minus cos t equals sin square t plus cos square t minus 2 sin t cos t. So, as we know that sin square t plus cos square t is a what? 1, and 2 sin t cos 2t equal what? Sin 2t, sin 2t. So, here now this can be written as what? 1 minus sin 2t, 1 minus sin 2t. So, Laplace transform of a, now Laplace transform of a ft equal Laplace transform of a sin t minus cos t whole square equal Laplace transform of 1 minus sin 2t, sin 2t. And we know that using the linearity property, Laplace transform of a 1 minus Laplace transform of a sin 2t, Laplace transform of a sin 2t. So, Laplace transform of a 1 is a 1 upon s, and Laplace transform of a sin 2t minus sin at be the a upon s square plus a square. So, here a is a 2. So, 2 upon s square plus a square be the 4. So, after simplification, this become s into s square plus 4, and in a numerator this become s square plus 4 minus minus 2s. So, this one is a what? This one is a s square minus twice s plus 4 upon s into s square plus sorry. So, this one is a what? This one is a Laplace transform for sin t minus cos t ka whole square using the elementary function. Third question is a Laplace transform of e to power at minus 1 upon a. So, how we find? Third question is a Laplace transform of e to power at minus 1 upon a. E to power at minus 1 upon a. So, now again using the linearity property, again here once we write the linearity property, Laplace transform of a C1 F1 t plus C2 F2 t equal C1 Laplace transform of a F1 t plus C2 Laplace transform of a F2 t. So, this one is a what? This one is a linearity property. Later on we prove this one. So, here now Laplace transform of a e to power at minus 1 upon a be the constant, so this become outside 1 upon a inside Laplace transform of a e to power at minus Laplace transform of a 1. So, after simplification 1 upon a Laplace transform of e to power at is what? 1 upon s minus a, 1 upon s minus a, and Laplace transform of a 1 is a minus 1 upon s, because we know that by the result of elementary transformation Laplace transform of a 1 is a 1 upon s. So, if we simplify this 1 upon a inside this become s into s minus a, this become s minus s plus a. So, if we cancel out this one, then this a also cancel out. So, this become a upon s into s minus a. So, these are the some numerical problems. Now, here if we a and a cancel out. So, what is the value for this one? The value for this one is not a. Now, this become what? This one is a 1. So, what is the answer of this problem? The answer of this problem is a 1 upon s into s minus a. This one is a answer. This one is a answer. These three problems are based on a linearity property. Why? Because in first question, if we closely observe ft equal 3 into e to power 2t plus 4 into e to power minus 3t. So, if we compare with the linearity property, what is the C1, what is the F1t, what is the F2t? Here C1 is a 3. Here C1 is a what? C1 is a 3. This is a C1 and this is a C2. So, here we take outside the C1 and C2, find the Laplace transform of F1t, Laplace transform of F2t and multiplied by 3 and 4, then we able to find out a Laplace transform of this whole function using the linearity property.